Hello, everyone. I'm excited to be today with Jaimie Johnston, Board Director and Head of Global Systems at Bryden Wood. We are in sunny San Diego today at EU 2024. It's been great time here. Hi, how are you?
Yeah, very good, very good. And yeah, thanks for asking me to come and have this chat. I'm looking forward to it.
It's always great to learn from new innovations in offsite construction from you, and we would like to share today your expertise with DfMA, offsite construction, and to talk about what really the future could be with offsite construction.
Yeah, perfect.
Can you tell more us about your expertise and what the great things you're doing at Bryden Wood? You received an MPE in 2021. You've been a champion for offsite construction over the years and pioneer with DfMA. Would love to hear about the latest and greatest you're working on right now.
Yeah, okay. So for those who haven't come across us, Bryden Wood, we're an integrated design consultancy. So we started out as architects, and then we got mechanical, electrical, civil, structural engineers. We also now have industrial designers, product designers, data analysts, coders. So we've got quite a broad range of capabilities now. We've had a very strong focus on DfMA or industrialized construction we'll be 30 next February actually, which is a bit scary, but for nearly 30 years we've been doing this. We tend to work with sort of major serial repeat clients, so data centers, pharmaceuticals, those sorts of things. And we're doing an awful lot of stuff at the moment around, we call it introduction of new technology or industrialization of new technology. So things like the pharmaceutical industry is massively decarbonizing their drugs, and they're also shifting from, traditionally they would make batch production, they would make millions or billions of doses of a thing. Some of the medicines now are so potent and so highly targeted, they might make 40 doses, 100 doses. So they're shifting from traditional batch production into continuous, they call it, or hybrid production. So that's a big shift in the pharma industry. We're helping lots of clients navigate that. Or there's lots of new technologies emerging, carbon capture technologies particularly, that if they're going to have any impact, you don't do one or two deployments, you do 10 or 100 or 1,000 of these things. So they're having to move very quickly from the technology being discovered to technology being able to be delivered at scale. And we're helping lots of clients with that sort of thing, of working out how to scale up and deploy these things almost as products. So this sort of shift away from projects into products, that's a big thing for us at the moment.
And what technologies and tools are you doing that to adapt with the growth for your clients as buildings become more complex and expand globally and in scale and in complexity too with MEP systems? What tools and technologies you utilize to accomplish that?
So we have a thing we call chip thinking, where we try and take either buildings or processes, we break them down into the kind of value-adding steps. So if I give you a healthcare example, you never get a theatre on its own. There's always the theatre plus the anaesthetic room, clean room, clean data circulation, staff, consumables. So we try and break buildings down into the sort of building blocks, optimize each of those individually, then work out the rules for how these things go together. So what chips, we call them, have to be together, which ones have to be separated. So we develop these sort of building blocks and sort of configuration rules. We then spend a lot of time with clients. We talk about scale up versus scale out. So if you're doubling the capacity of a manufacturing process, do you have one vessel that's twice as big, or do you have two vessels at the same size? So we use those techniques to develop the rules for how you can configure things, and that makes it very, very scalable. Because you can take those building blocks, you can take a particular brief from a client and a particular site with its constraints, and you have a ready-made way of how to configure the sort of Lego blocks that make up the building. So that allows us to move very quickly, look at sort of multiple sites for clients. And obviously you're trying to turn those building blocks into manufacturable products that you can also make at scale in different markets. So bringing all those things together, we're trying to sort of constantly, we talk about sort of standardizing at component and process level, but giving complete freedom at asset level. So we're constantly trying to balance that tension of creating a suite of solutions that are adaptable enough that they can be applied to lots of different sites without losing the kind of benefits of the standardization repeatability. So we've learned how to do that over lots of
That's a great example of how you're using one module and you tweaking it with a little bit creativity and innovation to match and be tailored to your client needs for the growth for each project. That's a great approach to do that.
Yeah, so we started out as architects. So we have this thing that if ever the industrialization is forcing you to compromise the quality of design, you're doing it wrong. Like you should always be sort of led by what the value, the client is after, what good looks like for them, and the industrialization should always be in service of that. And we've learned how to do that over lots of years.
Over the last few years, supply chain has been a challenge for the construction industry. How you build at Bryden Wood integrated supply chain to support your projects?
So we actually do quite a lot of, certainly in Europe now, we're starting to do more and more market analysis, supply chain analysis for clients. So one of the things we've learned is if you develop a industrialized solution that's so complex no one can make it, obviously that's a problem. So we tend to be doing quite a lot of analysis now of what is the sort of capacity and the capability in the supply chain, and we're sort of designing towards them. So we're designing towards things that we know can be manufactured. Maybe it's a slightly new thing for them, but we know it's within their capability. So that's been quite an interesting thing. So also working with clients and saying, which things could you just have a completely standard off-the-shelf, component? We don't need to invent everything from scratch. So again, if you sort of look at which things you can buy literally off the shelf, design the other bits in a way that links them up, that's massively helpful, because obviously, certainly in the data center world, lead times are incredible now. So you just want to be buying, relatively standard things. So we do quite a lot of that. The other thing I think we do is for certain clients, they will have PCSA, pre-contract services agreements with suppliers. So in a sort of traditional procurement route where you're, competitively tendering and you're trying to screw every last cent out of your suppliers, that really doesn't create the right behaviors, and they will be looking for change orders. They'll get that money back somehow. So some of our more sophisticated clients will actually go to supplier, pay them to do some work up front, pay them to help develop the thing that we're, the prefabricated elements we're developing, so the supplier knows that they can make them because they help to build them, creates the right sort of behaviors because they know their profit's going to be covered. So changing that sort of relationship between customers and suppliers, that's been quite a powerful thing. And it's what automotive does very well. Like all the automotive people are partners with their supply chains. It's not a transactional thing. So trying to encourage customers to get into that sort of mindset, that's massively helpful.
And identifying long lead items early on in projects help.
Yeah. There's certain things now for certain clients where they're saying we have to place an order for these bits now.
Yeah.
So that's what we'll have. You have to design around those and make sure you can incorporate those, because some of these things now, the lead times, the supply chains are all very stressed. They're all being targeted by multiple big serial clients. And so helping to kind of facilitate that by saying what can we do to make it easier for you as a supplier to engage, that creates the sort of ecosystem that you need.
You brought up a great point, Jaimie, earlier about construction industry, maybe one of the very few industries that's doing things from scratch every time.
Yes.
And that doesn't make sense from a sustainability point of view and efficiency point of view and cost effective. Like we can learn a lot from automotive industry, for example, on how we can take a unit that's already done and tailor it to that to increase efficiency.
Yeah.
How Bryden Wood is using that example to boost sustainability and reducing carbon footprint.
So what we found is, firstly, if you're going to create a sort of design for manufacture and assembly sort of component, that you're going to use a bunch of times, you can spend huge amounts of time designing that element because you sort of amortize that design over lots and lots of deployments. So certainly for the components that will be used at scale, we will spend hundreds of hours taking out every single gram of material we possibly can, making the thing as lean as we possibly can. So obviously, less material, that's one huge benefit. We often use the examples of, if you think about multi-trade racks, so above the ceiling in lots of buildings, there's the structural zone, the pipe work zone, the ductwork, cable tray, lighting, ceiling. So like 20% of lots of buildings is completely useless ceiling void. But that's all air that you have to heat and treat, and so the running cost of your building is dictated by these massive voids. So traditional construction does that because it's easy to coordinate if nothing's clashing. Individual trades can go and assemble their bits and not get in each other's way. We would be constantly we talk about increasing cost density. So you can take all of that stuff and compress it if it's going to be made on a bench, by a person dropping all the bits in. So again, if you look inside an iPhone or in under the hood of a car, like there's no wasted space. They've worked out how to absolutely compress things. So we do a lot of that sort of stuff to increase cost density, but then your logistics get better. There's fewer vehicle movements. You'll have fewer operatives on site. We actually did a commercial office in London recently. It was the first net zero commercial office. We used all of these tricks to use less material, create less building volume, make the best material choices, control logistics. So we brought all of these things together to reduce the embodied carbon. One of the benefits was that we could fit, because the MEP was so compressed, we could fit 11 stories of office in what would normally be a 10-story volume. So because the floor heights are less, you've got less air to heat and treat. So one massive benefit was obviously we took tons of carbon out. A huge commercial benefit is you can get more building in the same volume. So if you're a commercial office client, your rate of return increases. You go, right, that's a huge financial benefit. So we're constantly trying to do these things where we're, reducing carbon at the same time making a much better product with a much better higher rate of return. So I think in certain instances, people assume that DfMA will be more expensive. You go, if you're doing it like that, you're doing it wrong. Like, you should be able to get lower cost and lower carbon and faster construction and all these things. You shouldn't be trading off. But yeah, that was, I think, a really good example of doing an incredible sustainability job whilst also making a much better product for the end client.
And Jaimie, how we can push in the industry using these methods, these all innovative methods, into more building types? It doesn't have to be an office building, for residential, for every building type. Is there a way you think we can push that forward?
I think all the things I've talked about, this sort of trying to increase cost density. So we've done lots of different versions of residential. Say, if you look at the complexity in a residential, building, there's only a tiny amount of stuff. There's the kind of entrance hall and the bathroom is broadly where the consumer unit and the air handling and the plumbing and the gas and things comes in. You go, there's a tiny bit which you could compress and get almost all of the complexity in an apartment in one box, because everything else is relatively straightforward. So that principle of saying, can I compress things into the smallest number of, most cost-dense components and make everything else quite dumb? So that's, I think, one of the things we have learned is that you don't have to industrialize everything. If you can compress all the complexity into one bit and you make that as a DfMA thing, actually, I'll give you an example. We did a hospital project. We tried not to put any services in the walls. So all of the services were done as a kit of parts compressed into, in the inpatient rooms. It was the bed head. We then gave the entire floor plate to the dry lining crew or the drywall crew and said, no one will get in your way, off you go. And they will tear through a building with incredible productivity if you just let them get on with it. They're quite slow in traditional construction because they do the first fix, then someone comes and puts the pipes and the wires and damages the wall, then they come back and fill it up. So that thing of often using quite traditional methods, but giving the crews that are doing it a completely clear run. So we talk about trying to create factory-like conditions on site. So if I can get the kind of productivity benefits of a factory without actually having a factory and doing it on site, you go, that's even better, isn't it? So that mix of knowing when to prefabricate something and make it, cost dense and off-site, and when to do something quite traditional but in a more productive way. Again, that's been a hard-learned skill.
You're bringing up a great point, Jaimie. I've been working on modular construction over the years, and rather the off-site, built miles away, has to coordinate with on-site, and the sequencing that job. I love what you said about you don't have to prefab everything. It could be a hybrid approach that can be the answer for efficiency.
Yeah, I actually hate the term off-site. I've got a problem with it because it sets the wrong mental picture. So in the UK, there's been lots of volumetric modular housing things, and I think by lots of people's admission, it's not manufacturing, it's construction in a shed.
Yeah.
Like all you've done is displace the problem into a shed. And now you've got the cost of the factory and the transportation, all these other things that you didn't have before. But people go, well, you said off-site. So their mental picture is doing everything off-site. And you're going, that was never the exam question. The exam question was carbon, productivity, safety, quality. the exam question isn't can you do it off-site, it's can you tackle these other things.
I agree.
And actually the way to do it is not necessarily to do it off-site. If you can do it highly productively on-site, that's loads better, isn't it? Because now I don't have all these other costs that I didn't have. So yeah, like I think off-site has kind of led people sometimes in the wrong direction. They take it too literally, and you go, and actually it was never really about off-site. We like the term design for manufacture and assembly because it's not the product, it's the process. If you're going to manufacture and assemble something, you have to design it in a particular way and think about it in a particular way. And I think just blindly saying, we'll stick it all off-site, you go, no, you've gone too far. Like there's nuances to this.
Absolutely. Totally agree with you. Can you tell us elaborate more about the BIM to manufacturing workflow, how you achieve that from the early beginning, from design to fabrication to on-site installation?
Yeah. So we were, I think, very early adopters of some of the tools that, say, Automotive were using sort of back in the day. So we always had an interest in owning the design right the way through to fabrication. We actually have our own prototyping facility. We did run our own factory for about 8 years. We don't do that anymore, but we thought it was necessary to really understand, the entire process and understand the kind of construction implications of your design decisions. So we started using, quite advanced digital tools before BIM was a thing. Then when BIM started being introduced in the UK, I was part of the UK task force because we were kind of identified as early adopters of these digital tools, but also using them in a way that was going to tackle productivity and things. So we were very early adopters of sort of BIM workflows. I think the thing I talked about, the chip thinking, we've learnt now how to do, we often use quite geometrically dumb models to do the configuration. Somewhere we will have, an incredibly LOD 400 version of it. Somewhere we'll have a sort of LOD 500 plus version of it. I don't need that for the configuration phase. And obviously, as soon as you've got a completely federated model, it's big, it's heavy, it's hard to manipulate. So we tend to use that chip thinking approach to do configuration very, very quickly with these sort of simple building blocks. When we have a configuration we're happy with, you go, right, now go and get all of the, the LOD 400 bits and drag them back in. So we talk about fine grain and coarse grain components. So we'll use the kind of coarse grain ones to do the kind of configuration. We don't really want the fine grain ones all federated until the last possible minute. But so we have a whole series of these workflows of using different digital tools at the different stages and joining them up. But yeah, we're trying to resist having a sort of big, heavy model. We want the data, not necessarily the geometry. And yeah, focusing on that sort of thing.
Love that. It's all about the data embedded in there.
Yeah.
Let's shift gears a little bit about assembly on site and how you empower your labor to ensure that everything is assembled correctly. What tools you use to do that?
Physical prototyping has been a big thing for us. So we'll often build a prototype in the office of something that is dimensionally correct, but using completely the wrong materials. So we'll use, say, MDF that's painted to look like steel to represent, a steel beam. And from about 10 feet away, it looks like steel until like someone picks it up and walks off and they go, all right. So we'll often, when we did the prisons program for the UK prison system, we made prototype cells out of foam boards in our office. We were using that to say, I've got a certain number of square meters. What's the best way to, is it better to have a sort of narrow, deep cell or a wide but shallow cell? So we'll go through a sort of that kind of dimensionally accurate but wrong materials. Then we'll do dimensionally accurate and correct materials. Then we'll often do a process prototype where we're training people how to assemble the components. So for the prisons program, we actually set up a prototyping facility inside the prison, trained the prisoners how to do it. So we were getting metrics out in terms of, labor, productivity rates, these sorts of things. Obviously, that helps to refine the design. You learn all the problems and the issues and the things that are, difficult to align. So prototyping and trying to learn as much as you can digitally and then physically before you get to a live site, that's been massively powerful for us. So wherever possible, you want to be doing all your learning in a safe, controlled environment where you can make mistakes and correct things. By the time you get to a live site, it wants to be a choreographed sequence of activities, not people turning up and going, well, what am I going to do next? And how do I do this? And where's the tools and things? So we're trying to get, again, by the time you hit site, you're trying to get these sort of factory-like conditions. But that's been enormously powerful for us, sort of prototyping and testing things, training people how to assemble these systems, and so it becomes actual assembly, not construction when they hit site.
Yes. And it has a positive impact on the community and for people to learn the new skill sets which we need for our industry as well.
Yeah, the prisons thing was interesting. They're an amazing client. The Ministry of Justice were phenomenal. They allowed us to do this prototyping. And people thought it was a bit strange that the prisoners were building bits of the prisons program, but actually the problem statement from the MOJ was rehabilitation. So people come out of prison, can't find work, go back to prison. That costs about £18 billion a year in the UK. So we're saying if you could use the building of the prisons program to upskill a bunch of existing prisoners, and you created a market where they could then come and start to manufacture things. First, you'd use the building of the prisons to kickstart the rehabilitative thing that they're there to do. Everyone knows we've got a huge skills gap, aging demographic problem. So you could suddenly address that and go, actually, all the people in construction are going to be maxed out for the rest of their careers. We have to find a way to backfill. So if suddenly you could engage and mobilize prisoners, ex-prisoners, ex-servicemen, unemployed people, you go, your skills gap disappears. You create a whole load of new jobs and opportunities, and you start a new manufacturing
and change people lives to the better, have a bigger impact on the community. That's a great example on how our industry can really have a positive impact for the whole community. And provide opportunities for everyone.
So I often quote this stat. There's currently 8.2 billion people in the world, and there's UN predicts we're going to top out about 11.5 billion. So it's like 3 billion people on the way. And we have to build schools and healthcare and education and transport infrastructure for another 3 billion people within a few decades. And the quantity of work that's coming is unbelievable. We have to build at a pace that we've never achieved, with a kind of low carbon intensity that we've never achieved at massive scale. Again, that's not construction. We have to do a different thing. So the idea that you could suddenly mobilize displaced communities, you could train them up and they could be building their own communities. The fact that you could, upskill a bunch of people who are disenfranchised. And again, this is how we have to do it. We have to find ways to vastly increase our capacity and build much quicker with the people we have and do all these things. But yeah, the only viable way we think you can do that is through industrialization and simplifying construction to the point where you can take this whole community of people and train them up and empower them and, all the rest.
What if there is one thing you'd like to change about our industry, what would it be and how?
The thing that the massive blocker now, and we sort of touched on it earlier, the kind of shift we need to make, technically everyone knows we need to do it, and there's loads of examples of how it should be done. The thing that's in the way at the moment is all of our business models and commercial incentives and procurement practices and contracts and risk, attitude to risk are geared up to do one-off bespoke projects every time. So, the big thing we need to change is the culture and the mindset. That'd be, if you change one thing, it would be that. That's obviously a massive, very, very complicated thing.
If we can change the mindset, we can change a lot of things, is it?
Yeah, it's not a technical thing now. It is a cultural thing. And it's an interesting thing. Like when we started, construction didn't think it had a problem. We're going, we seem to build things. We don't kill that many people. What's your beef, Mona? And I think now at least everyone recognizes that there's some huge challenges. Everyone knows we need to change and it gets talked about. So admitting you have a problem is the first step. So I think that's, super helpful. Things like health and safety have gotten dramatically better in the last 30 years. And you go, that's great. It shows the industry can focus on an issue and change things and make things better. Obviously, digital's a lot more prevalent now. So you go, there's some really good positive signs, but it needs to happen very quickly. But yeah, this cultural thing, we have to get over the kind of project mindset. We have to start moving into this more, serial product industrialized mindset. And that is obviously a massive ask, but that's where we need to be.
Absolutely. And I think we're moving forward towards that direction. There's a lot more awareness now about industrialized construction and how it increase efficiencies and push it throughout the life cycle of projects. Here at EU in San Diego, it's been an exciting few days.
It's been great.
What excites you the most? The technologies you have seen. We have seen yesterday the construction keynote was really amazing to see how other construction companies like Gamuda was doing.
Yeah,
It was
yeah.
amazing to hear about that. What most excites you and see as an opportunity for us for the EEC industry next year?
I think it's probably illegal not to talk about AI. It's like every conversation I've had with people as someone's mentioned that. I think that I was amazed actually. The opening session, Andrew Alingnos talked about what Autodesk are doing with AI. I was amazed actually how advanced their thinking is, and actually their attitude and the things they're doing. You're going, yeah, if you were going to apply it to construction, I've been interested for ages to see how AI is going to come into construction. I think what they're doing actually is it's quite sophisticated approach. My sort of note of caution, I suppose, so I don't know, I'm not an expert in this, so obviously I've got an opinion on it. I think there's something interesting about AI, that it's obviously only knows what was in the training set. AI will get you to the kind of current best answer very quickly. It won't do the kind of innovative steps. So a lot of the things we've done for clients, the best things have been when we've not done what a client asked. So they said, can you make this facility? We said, we could do. Should we? Maybe you're answering the wrong question. Or Martin Wood, the co-founder of Bryden Wood, makes these incredible imaginative leaps and joins technologies or links ideas that are completely, come out of nowhere, and you go, oh my God, like we've all moved forward because of that. So I think my sort of note of caution is, I think AI will have a positive impact on construction. I think we will, if we can use it and embrace it as a tool, it will help us to get much, much better at certain things. We can't forget, though, like the amount of innovation we're going to have to do over the next few decades. AI won't do that for you. We can't sort of just rely on it and autopilot into doing more of the stuff we've already done. We have to sort of step back and hopefully use it to free up more time to have these sort of creative sparks, these sort of innovative things. And I think if we can balance the two, then I think we're in a good place. But yeah, I now think it's going to be quite an interesting. I'm more optimistic about AI coming to construction than I was 4 days ago.
Great point. It's an empowerment for us
Yes.
to do more our work more efficient. Thank you so much, Jaimie, for sharing your expertise and for being with us today in San Diego.
No, thanks again. It's always good to see you. Always good to catch up.
Thank you so much.
Thanks a lot.